Hi, I'm Bruce Schwab with Ocean Planet Energy, and we're on board the Vivi, a semi-custom Gunboat 57 that's one of my favorite projects over the past few years that has our energy systems on it, from batteries to solar panels to high output alternators. It's just a great package combining lightweight and efficiency with the battery capacity and horsepower to run some pretty nice amenities that you would like to have on this kind of a boat. The monitoring on this boat is C-zone. This boat has a pretty considerable solar array on it. The port solar panels are monitored independently from the starboard solar panels, so this will vary a lot depending on shade as the sun moves and shade moves, but we're getting 20 amps, 20.7 amps at almost 26 volts on the port side, in addition to 13 amps at almost 28 volts on the starboard side here. You are probably used to thinking of 12 volt current. So if you double this amperage, then you're looking at what you'll be getting in 12 volts. So this is like 42 amps equivalent in a 12 volt system. There's a lot of power. So this boat can run a lot of stuff just off the solar without even having to start the engines. Up here on this boat, each solar panel has an individual Jenison GVB boost controller. And the advantage of having individual controllers is that in any kind of partial shading, if you shade some panels, it doesn't affect the other ones. They're all independent. So you have the least loss in partial shading, which on a sailboat is a constant problem. You have the boom, you got shade, you got all kinds of things that could shade it. But when you have individual controller for each panel, then it won't affect the other ones. And so you wind up with much more net output in partial shading conditions with this setup. Now, it's a 24 volt boat, which usually the controller wouldn't work because it's higher voltage than the solar panel might be. But that's the special feature of these Jenison GVB controllers, is that they raise the voltage of the panel up to the battery voltage. So you can use a 9 volt panel and charge a 24 volt battery. So these are all GVBs that are charging the 24 volt lithium battery system. They're specially programmed for the lithium batteries in this boat. BMS power buttons. BMS stands for Battery Management System, and those turn each of the 3 battery banks on. And they're connected to the control box that runs each battery. That's like the master power switch. If those are off, then everything downstream of there is off. So up here we're checking out the Solbian SP panels. These are made in Italy using the highest power solar cells available. These are SunPower Maxion cells in these panels. And these for years have been the highest power solar cells you could get, and the highest power custom panels you could get. We now have some new panels made by Merlin in California that are as powerful as these, but these are fantastic solar panels. And there are 6 per side on this boat, each with an individual solar controller, which is what we were looking at earlier in the cabin overhead. Each one has its own controller. So if any of them are shaded, for instance, obviously the boom is up here a lot, and over there we have the boom shading several panels, but one of the panels over there is just outside the shade, and that one will keep producing because they're all individually controlled. On a residential installation or on an installation where there's no shading, then you would have the panels all connected together in series to create essentially one giant solar panel, which makes the wiring simpler because you only have one set of wiring coming down. That works great on a house where there's no shade, but on a boat, you're much better off with individual controllers. So we're up in the tech area of Vivi, and this is where the 3 lithium battery banks are and all the DC power distribution and connections. It's up pretty far forward in the boat to keep the weight forward, but since they're lithium, they're not nearly as heavy as they would be if they were lead. So there are 3 banks in here. Each one is 300 amp hours at 25 volts. So it's a 900 amp hour system in this boat, which is a considerable amount of power. I think it's like 22 kilowatt hours in this boat. Each bank is independent, but they're all running in parallel. So it operates as if it's one 900 amp hour bank. However, if any one of them went offline, the other 2 won't be affected. Here you can see the 3 BMS modules, which means battery management system, and those are the control boxes, one for each battery, that control the charge and discharge of the system. All of the contactors that can cut off the battery and protect it are inside these boxes. And as complicated as this stuff may look, this is much less complicated than earlier lithium systems where you had to install all the contactors manually. Here they're all inside the box. It bolts up much simpler and much faster to install than the old way of doing it. Even with all that though, as you can see in the overhead there, all these systems in a boat like this requires a lot of cabling and requires a lot of preliminary work, electrical diagrams and study to make sure you have a safe system that can deliver the kind of energy needs that a boat like this has. AC power is a critical part of all these boats because many of the high loads run on AC. So whether it's a Master Volt, this is a Master Volt Combi inverter charger, or whether it's a Victron inverter charger, they convert the DC power to the AC loads to run air conditioning, microwaves, water heaters. You can run all that stuff off the batteries through these inverters. You just have to make sure you have enough inverter power to handle your peak loads and enough battery capacity to run them for as long as you want to before it's time to recharge. Yeah, so we're still up front in the tech compartment. This is the starboard side where I'm in, where one of the 3 batteries resides, and also more of the power conversion devices. As on the port side, you can see there's plenty of DC distribution, which means cables running out to support all the devices and all the loads and all the charging sources. This is the load bus, so this all heads off to run whatever's running on the boat. Charge bus over here, so alternators and solar panels, they find their way to this. So this, by bus we mean it's kind of where a collection of cables connect up. Our BMS systems with the lithionics batteries that are in this boat uses what we call a dual channel system, where the load and the charge sides are separate from each other. The charge side will have the alternator, solar panels all coming in, and the load will have all the loads coming out. And the reason for that is the BMS systems can individually control those. Let's say you have a low voltage situation where you've run the inverter or something down to a low state of charge. The BMS can cut off that load side but leave the charge side connected. So the solar panels are still connected to the boat. Let's say you're not on the boat and it's an unintended situation, but when the sun comes up, the solar panels will start charging through the still live connection on the charge side, charge bus, and then when the voltage starts coming up, the system will automatically turn the load side back on. But it prevents the system from getting over discharged and shortening the life of your batteries. The engines in this boat have been moved to the middle to keep the weight centralized, which for performance purposes and sailing balance is a big improvement. It's one of the things that was customized on this boat. So these engines are up here with centralized weight, and they have special high output alternators. You can't see it, but down there on the other side of the engine, you can see the pulley. These are custom pulleys. There's a custom pulley on the crank with larger diameter that moves the belt faster to rotate the alternator faster to give you better charging output. That's what the alternator's for, is to charge the batteries, to get better output at lower RPMs. And that way you get the most charging and energy into the batteries for the least amount of fuel consumption. You can be motoring along at moderate speeds but getting very high output and charge into the batteries at the same time. And this is part of the energy systems in these boats, of these high efficiency alternators, to eliminate the need for AC generators. In the past, most of these boats would have a separate diesel engine. There was an AC generator that produced AC power, and they'd use the AC-DC chargers to charge the batteries while they ran the air conditioning or whatever with the generators on. And they used to leave the generators on for hours and hours and hours or all night long. But now, because of the increased battery capacity of the lithium batteries. You can run those high loads for long periods of time. And then when it's time to charge, these high output alternators can just push an enormous amount of energy back into the batteries at a very high rate and load the engine up enough to where it's good for the engine. The one thing you don't want to do with a generator or the propulsion engine, any diesel engine, is run them under low load, and shortens their life. So, but diesel engine likes to be doing some work. So if you're motoring the boat along, moderate speed, get in the morning, you put air conditioning all night long, motoring the next anchorage. While you're puttering along, you're charging the batteries at the same time. Engine's happy, it's loaded, it's producing energy, moving the boat at the same time. It's the most efficient use of the fuel. We all want to use as little fuel as possible, you know, for environmental reasons and lifestyle reasons, and just not have to listen to it any more than necessary. So we achieve all that with this configuration.